So in this video, we're going to analyze what's pretty much the most basic circuit we could ever have, a single voltage source and a single resistor. And we're going to find all the possible currents, voltages, and power for each element in this circuit here. And we're going to use all the knowledge we have so far. So let's see here. We got two elements here. One's a 6-volt source, one's a 2 ohm resistor. We know that since they are connected in the bottom and the top, they are in parallel. And if they are in parallel, that means they have the same voltage. So the voltage for the resistor, I'm going to call this a VR. The voltage for the resistor is going to be the same, 6 volts here. Now, if we know that the voltage for the resistor is 6 volts, and let's go ahead and talk about current now. So I'm going to go ahead and label the current going in this clockwise direction. Notice since everything is just a single connection, current has no choice where to go. It's all going to be the same current. So by Ohm's law, it's going to be the voltage divided by the resistance. So my current there is 3 amps. Then if I wanted to find, say, the power for the resistor, I would do I times V. So the current of the resistor is 3 amps. The voltage of the resistor is 6 volts. And since I'm having my current drawn going into the positive side of the terminal, I would use the regular power as I times V, not the negative version. It's passive sign convention. And so the power of the resistor is 18 watts here. Then if I look at the source here, for the power of the source, I have a voltage of 6 volts again. I have a current of 3 amps. But this time for the source, the current is coming out of the positive side, not into it, which means it is not passive sign convention, which means it is an opposite sign here. And so the power of the source is negative 18 watts. And so we have the following here. For the resistor, the current is 3 amps. The voltage is 6 volts. And the power is 18 watts. And for the source, the current is 3 amps. The voltage is 6 volts. And the power is negative 18 watts. And by the way, if you add up all the powers in your circuit, it is always going to give you 0. And that's because the law of conservation of energy is guaranteed that the total energy is always going to be the same. And if you do the derivative of that, that means the rate of change of energy, which is the power, will all add up to the derivative of a constant, which is 0. And so you see, we did all this work here, we found all this information, and that right there is completely solving a circuit. Now imagine instead of one that we had one source and one resistor, what if I had 5 sources and 30 resistors? It's insane to try to go through and find every single current, every single voltage, every single power. So usually when we get to the more complicated circuits, instead of asking for everything, we're just going to specify, find this voltage and that voltage, or maybe find these 2 currents here, or let's just find the power on this one resistor on this side here. So in the future, we're going to have more complicated circuits, but we're only going to ask you to find certain things instead of everything. Now with that said, that's something that you're really going to want to think about, because a lot of the techniques that we're going to learn, you're going to have variables for everything. And if you just set it up, you're going to have a system of maybe 6 equations and 6 variables. And sure, you can solve that and you can get 6 answers. But maybe there was a better way to set the problem that didn't use all those variables because you only cared about maybe 2 of them in your problem. So one of the things just to keep in the back of the mind as we're going through future chapters is, sure, you could find every single thing in the circuit, but if you can find a clever way to only solve for the things you're looking for, you're going to make your life a lot easier. And definitely something you want to do is make your life easier in this class.